So for today we'll concentrate on the motion in the straight line. So the motion in the straight line, with these questions are the one that we'll be dealing with for today, for as we start. So the motion in the straight line, which is question what? Question 1. So this question 1 says that a cheetah waits in a hiding behind a bush. The cheetah spots a gazelle running past at 10 meters per second. At the instant the gazelle passes the cheetah accelerates from the rest at 4 meters per second to catch the gazelle. So the first question says, how long does it take the cheetah to catch the gazelle? So before you do anything, you need to take the data. So meaning that here we're supposed to take the data. So we have the cheetah this side, and we have also the gazelle this side, like that, right? So the cheetah, it was moving at what speed? The cheetah spotted a gazelle which was moving at what? This is speed, meaning that the velocity of the gazelle that it was moving at 10 meters per second. How about the acceleration of the cheetah? The acceleration of the cheetah, it was 4 meters per second. Remember that the cheetah started from the rest, meaning it's supposed to be what? If it started from the rest, means supposed the initial velocity to what? Be 0, like this. Then here acceleration will be equal to what? To 0. So meaning that the equation that we use this equation. Like that, right? So the displacement final is equal to, what is the initial speed? Is 0, like that. What's the time? T is the one that we're looking for. Then here the acceleration was 4 in the question, such that you come up with this. This is 0 plus 2 80, or plus 2 t what squared, meaning that your final displacement for the cheetah was 2 seconds, like that. How about on the gazelle? On the gazelle we use the same thing. Here the velocity was 10, initial velocity was 10, then the acceleration was 0, like that, such that it is 10 here, 10 what? 10t plus 0. So the other equation, it will be 10t, like that. So what really are we looking for? Remember, in this equation we're looking for question 1. We're looking for the what? The time that it took, for the time that took the cheetah to catch the gazelle. So meaning that we have to equate these two equations. We have to say t2 squared is equal to t10, like that. Then here is supposed to be t2, then t2t, like that, and this. What will remain here? You remain with t. Then when you divide here, to be what? 5 seconds. So meaning that it took 5 seconds for the cheetah to catch the gazelle. So this is how you answer on the first question. So the second question, they're saying, what is the displacement of the gazelle and the cheetah? So for you to find the displacement, of the gazelle and the cheetah, we use these equations that you have been given. This equation, the one that we found here, which is what? X final is equal to t here, like that. Then where there's t now here, we replace with what? With 5, such that I'll find the answer, which is 5 times 5, it is 25 times that, would be what? 50 meters. So meaning that here saying, what is the displacement of the gazelle of the gazelle and the cheetah? It is 15 meters, or even if 50 meters. Even if I get this one, meaning it will still give me what? 50 meters. So again here you find that it's what? 50 meters. So meaning that these two things, they traveled 50 meters, like that. So what is the next question? The next question is asking us to find what? To find the they are saying that question C is saying we have to calculate the what? We have to find the what? We have to calculate, or we have to draw, sorry, which is C. So C says sketch a displacement time graph for this situation. So for you to sketch the time graph for this situation like that, remember that this side is what? Displacement. In what? In meters. How about this side? It's what? Time. In seconds. So what was the displacement these two moved? The displacement of these two moved, it was what? It is when you look, it is what? We found 50, right? How about the time at which this was caught? The time at which this was caught, we found it was what? It was it was 5 seconds. That's where it was caught. So me here is supposed to be what? 5 here. Then here you just draw your straight what? A straight line like this. Goes like that, and even here you draw just a straight line like this to show that this is your what? The displacement at which these two what? Moved. Then the other one, it is saying sketch the velocity what? Time graph. So how do you sketch the velocity time graph on this situation? So remember that this part is the velocity. Then this part is what? Time. Such that the displacement time graph, how will it go? Remember that the gazelle, it was moving at constant what? Velocity. So if it was moving at a constant velocity, meaning it's supposed to go just like that. And how about the jitter? It accelerated from 0, it went up there like that. So this is how it's supposed to be what? Drawn. So I can say question 1, we have what? You have found the question 1. So let's go on question 2. So on question 2, it says, now here it changes to what? Question 2. Question 2a, it says that a motorist traveling at a constant 15 meters per second passes a school crossing where the speed limit is 10 meters per second. Just as the motorist passes the school crossing sign, the police officer on a motorcycle stopped there, starts what? To pursue with a constant acceleration of what? 3.0 meters per second. So here you have the motorist like that. Here again we have the what? The police officer. So the motorist was traveling at what speed? It was traveling at 15 speed, which is the initial speed, right? Which is constant in short. Meters per what? Per second. again, meaning the acceleration will be what? 0, because this one is moving at what? Constant velocity. How about the acceleration? The acceleration is that it is what? 3 meters per second. And this means that our initial velocity is 0 because it started from the what? From the initial. Then the first question says, how much time elapsed before the officer passes the what? The motorist. At that time, what is the officer's what? Speed, and how far has each vehicle traveled? So in this situation, the things that you really need to do in this situation are, let's first find the equation of the what? Motorist. So we said displacement this side is equal to VI t plus 1 over 2 at squared. Here our initial velocity is 15t plus 1 over 2, then acceleration is 0, then t squared, such that your equation will be 15t, like that. Here we already know that is what? 0. Then x is equal to 15t. How about this side? It's just the same thing. We're supposed to be x is equal to VIT plus 1 over 2 at what? Squared. Our initial velocity is 0 here, then t here, plus 1 over 2. What's the acceleration? That is 3, then t what? Squared. This is 0 plus, when you divide there, it will be 1.5t squared. This is x. So x for the equation for police officer, it will be 1.5t. So from there you equate this equation, right, which is supposed to be 1.5t squared is equal to 15t, like that, such that it will be 1.5t minus 1.5t. This one and this one, they will divide. What you're remaining with? You're remaining with t. So t is equal to, when you divide there, you will find the answer to be 10 seconds. So meaning that for the police officer to catch the motorist, it took 10 seconds. So that is the first question there. This question say, how much time elapsed before the officer passes the what? The cheetah, or before the police officer passes the motorist. They are saying that at that time, what is the officer's what? Speed. So at this time, what is the officer's what? Speed. So how are you going to calculate that one? You say V is equal to initial velocity plus AT squared, such that what's the initial velocity on the police officer? Here, the police officer here is 0, plus what's the acceleration? The acceleration of the police officer is 3. Then here it's what? 10. That's the time. So it means it's supposed to be 0, then 10 squared, that's 100 times this one, it's supposed to be what? 300. Then your answer, you find that it is 300 meters per second, like that, right? So from there, oh, sorry, this one's supposed not to be squared. It must not be squared. Sorry for this. Sorry. Here there's a mistake, a bit of mistake. It must not be squared. Sorry, this is just a t, like that. So meaning the acceleration here is just 3, then the time it's 10, like that, such that it will be 0 plus 30. Your answer will come up to be 30 meters per what? Per second, like this. So this is your velocity. Since they're saying at that time, what is the officer's what? Speed. then and how far has each vehicle traveled. So how are you going to calculate that one? Now here you just get the same equation which is there, 15t then is equal to 1 5 there, right? Then wherever the t will replace with it 10, such that the displacement to come up to be 150 meters. That's the displacement on this situation. I'm saying how far has each vehicle traveled, 150 meters. So this is how you calculate like that, right? Okay, so let's go on then another question. Remember this was your A. Now let's go on the what? On the B. So on the B, what are they asking us to calculate on the B? On the B, so on the B, they're saying sketch the displaced time graph for this situation. So remember the distance, the displacement time graph. Remember this is the displacement, this side. Then this side is what? Time in seconds, right? So here the displacement was 150. So you just draw your 150 like that. How about the time? Time it was 10 seconds. So meaning that, yeah, again like this, just draw like that. That's your B. Then your C, the velocity time graph. Velocity time graph here on this situation, that's velocity time graph. So remember that this motorist was traveling at a constant speed of 10 meters. So meaning here it's supposed to be 10 here, right? Then you draw something like this. Then, excuse me, then on the time, remember it is 10 seconds, such that when you're drawing this is the graph of the police officer. It started from the rest, then it was increasing until they met on what? 10 seconds. Hope it's okay on that one. Let's try to go on question 3. So question 3, it says the position of the particle is given by, so this is question 3. I have to even write here to show that this is what? Question 3. So question 3, it says the position of the particle is given by, that is x t like that is equal to 3.0 t squared plus 0.5 t to the power 4 meters like that. So this is your displacement function. So the first question, which is A, it says calculate the average velocity between 1 and what? To 3. So meaning the initial time here it's 1 second. The initial time, the final time there, it will be what? It is 3 seconds like that. So what are you supposed to calculate? It's the average velocity. So the average velocity, how do we find the average velocity? We say average velocity is the change in velocity, change in displacement over change in time. This is how you calculate the what? The average velocity. So if you have this, we don't have the final velocity, or we don't have the final displacement, and we don't have the final the initial velocity. What are you going to do? You are going to replace this time into the equation, the time which is the initial and the time that is final into the equation. So how are you going to do that? Let's say final final displacement will be 3, then you wherever there's t, you replace with 3, which is square there, plus 0.5, then 3 here to be 4 here, right? Meaning that this is 27 plus this is 81, then 81 times that, it will give us 40.5. When what would be the answer here? To be what? 67.5 meters. So this 67.5 meters, it is the final displacement. How about the initial displacement? We go by saying we replace with this one which is here, we put 1 there, squared, plus 0.5, then 1 to the power 4, such that it will be 3 here, because 1 times 1 is just 1, then 1 times 1, that is that, it will be 0.5, like that. So when you add there, it will be 3.5 meters. Then this is what? Initial velocity or initial displacement. So for you to calculate the average velocity, you say the change in displacement over the change in time. You come to what's the final displacement? It's 67.5, which is this one here, minus the initial velocity, it's 3.5, over what's the time? The time which is the final, it is what? 3 minus 1, such that when you subtract here, you will end up to have 64 over 2. Then your average velocity to be 32 meters per second, like this. So this is how you calculate your average what? Velocity. So when you go in question B, so question B, they're saying 3B, they're saying calculate the average acceleration at t is equal to this, right? What are you calculating? The average acceleration. Remember the average acceleration is what? V final minus V initial over T final minus T what? Initial, like that. So if you have that, what are you supposed to do exactly? In this situation, you have to calculate the what? The velocity. So here it's the displacement. So how are we going to find the velocity? We have to differentiate this equation to velocity. So meaning if I say dx over dt, it will give me velocity. So meaning this one times this one, it will be what? 6t, then 2, this is 2 minus 1, plus this one times that one, it will be 2 here, then 4 minus 1, such that your velocity will be 6t here plus 2 to the power 3. Then remember the question is saying you have to calculate the average velocity between 1 and 2. So meaning that the final velocity, it will be replaced by what? By 3. So it will be 6 here, then wherever there's t, you replace by 3, plus 2, then 3 here, cube, like that. This is what we call 18. 3 times 3, that is what? That is 27. 27 times 2 to give us 15. 4. So if it give you 54 like that, then when you add, we'll have like 72 meters per second. Then that's the final. Now how about the initial velocity? The initial velocity will have something like 6, then you put 1 plus 2, then 1, such that this one, it will be 6 here plus 2, you end up to have 8 meters per second. Then you come to our formula, which is average velocity, average acceleration minus, this is the change in velocity over change in time, such that what's the final? The final here it is 72 minus 8 over 72 minus 8 over 3 minus 1. You will have something like, again, 64 over 3 minus 1 is 2, meaning it will be what? 32 meters per second square. This is your average acceleration. Then let's try to solve question C. Question C, what exactly are they looking for? They are saying calculate instantaneous what? Velocity. So to calculate the instantaneous velocity, remember we have to differentiate this one to have the velocity. So it is 6 t here like that plus 2 then t cubed like that. So instantaneous velocity, it will be 6 here, then you replace with that 2, which is 2 here plus 2 then 2 here, 3 like that. This is what? 12. 3 times that is 8 times that is what? 16. You end to have 28 meters per second like this. That's what you call instantaneous what? Velocity. So how about D? D, we are differentiating the velocity now, which is dv over dt. It gives us the acceleration. So meaning that it is here we have 1 times that, it will be 6 here, right? Then t minus 1 like that, plus this time that it is 6, then 3 minus 1, then you have the acceleration like t to the power 0 here, plus then t here, which is 2. Your acceleration need to be 6. This is 1, right? Any number to the power 0, it's 1. So t to the power 0, that's 1. Then times 1 times 6, that is 6. Then this one is just the way it is like that. Then your next will be 6 here plus 6. What is here? That is 2. Then what I have to replace with 2 here, right? Such that we have 6. 4 times that, it will give us, that's 4 times 6. 4 times 6, it will give us 24. Then meaning your instantaneous acceleration is supposed to be what? 30 meters like this. That's all. So this is how you will calculate this. Then for continuation on question 4 and other questions, it's coming. Let's wait and support. Let's subscribe. Yeah, if you want to help, you can help there and then. Let's comment, share everywhere. Shalom.